Alrighty, that's how we set up the barrel extension before we measure it. The lugs location has been pre-qualified in the CMM, so all we want to do is just measure the size of the chamfers. And the first thing we do, bring the part over, get it in focus. It's in focus, and what we want to do is we want to measure a circle. We're measuring its diameter. Six points on that side. And 6 points on this side. Now we measure the diameter. And based off the size of the diameter, we have a good diameter. That's done. We switch to CAD view, enlarge. I construct the point on the center of that circle. I turn the center of that circle into my origin. Done. So now I have the part. The center of the circle is X, Y, and Z origin. The part's locked down, it's round, so I don't need a planar axis right now. I'm just working off the center axis. And then from here, I'm going to construct a point, theoretical, based on the information I received from the engineer for the theoretical 100,000s. Since we're going from the origin over, it's only 50,000s. So my theoretical point is 50,000s from the origin. And that's done. I turn that theoretical point back into my original origin. And as you can see from the CAD model, the theoretical 100,000s would be 50,000s radial. That's where my theoretical point is. That's now where my new origin is. Alrighty. We'll go back over. Whoop. Now I'm going to travel over 83.5 thousandths and up 307 thousandths and 4/10. $83.5. $307.4. Based from my theoretical origin, I traveled across an X and up in Y, and now I'm sitting at the center of the intersection of the chamfer on the back side of the lug. I'm going to bring it into focus. going to rotate over to my crosshairs at the intersection. Rotate right there. Again, we qualified the position of the lugs from the front side on the CMM. So their true position with the MMC all passed. So now we have a center point to start to measure across the length of the chamfer. So I'm going to hit new. I'm going to 0 because we're locked into our coordinates. Then all I'm going to do is travel in X as the print shows to the bottom intersection. I have a value of 17 thousandths and 8 tenths. The print is 20 thousandths plus or minus 5. That log passes. I go back to 0. Zero, 0. I rotate to the next lug. At the intersection, I'm back to 0, 0, the original alignment. I travel over to the lower intersection. 17 thousandths and 1 tenth. 20 thousandths plus or minus 5. This passes. We do this for all 8 lugs all the way around.